Did you ever notice how some sounds are high and some sounds are low? Then you've noticed a difference in pitch. The pitch of a sound refers to how high or low it is. The higher pitch sounds have higher frequencies. Sounds with lower pitch have lower frequencies. Another way to describe sound is in terms of loudness. The loudness depends on the amount of energy in a sound wave. If you hit a cymbal with greater energy, it will make a louder sound than if you hit it softly. Typical sound levels in decibels. At 140, the threshold of pain is reached. 130 is equal to a jet taking off 200 feet away. 120 decibels is what it's like to operate heavy equipment. 110 is a nightclub with music. 100 is a construction site. 90 is a boiler room. 80 is a freight train 100 feet away. 70 is classroom chatter. 60 is a conversation 3 feet away. 50 is urban residence. 40 is a soft whisper 5 feet away. 30 is the north rim of the Grand Canyon. 20 is a silent study room. 10, and then 0 is the threshold of hearing, beyond which we won't be able to hear anything. So take a moment to stop and think about this question. Explain the relationship between high and low pitch and high and low frequency. And before you actually answer that question, here's a quick demonstration. Notice how on this guitar, when I play the thinnest, highest string close to the sound hole, I get this kind of sound. This is a higher pitch sound. Now if I go to the thickest, lowest string on the guitar and I play it, then I'm going to get this sound when I play up near the headstock, away from the sound hole. Listen again to the difference. High pitch, low pitch. Now, let's take a look at some waves. Here you can see a wave machine on FET, and we'll mess around with it later, but I just wanted to demonstrate frequencies. So right now, you can see the frequency is 1.5 hertz, and these waves have a certain frequency, wavelength, and amplitude. Remember, amplitude is the intensity of the wave, or how high or low it is on a vertical scale. I'm going to leave it at 7.5. I'm not going to change the amplitude of the wave, but I am going to change the frequency. So as I increase the frequency, notice that we get more waves in the same amount of time. But something else happens as well. The waves get shorter too. As I decrease the frequency and make it a lower frequency, notice that the waves become fewer and their wavelength is greater. So they're longer waves, but there's not as many of them. Again, a high frequency means more waves in the same amount of time, but they have a shorter wavelength. And a lower frequency means I get fewer waves in the same amount of time, but they're longer. So listen now to what a high-pitched frequency like this would sound like. Now listen to a low frequency like this and what it would sound like. Again, listen to the pitch of a high frequency and listen to the pitch of a low frequency. Now that we've watched a demonstration and heard the connection between frequency and pitch, write down what you think a high frequency pitch would sound like. So in other words, if there's a high frequency, what would the pitch sound like? Would it be low or high? And then write down, if there's a low frequency, what would the pitch sound like, low or high? And then you might also want to say something about frequency and what that means. How there are more waves when the frequency is high, and there are fewer waves when the frequency is low.